Now we're going to move on to solving logarithmic equations. It's basically the same idea. We've just got to deal with logs to exponents instead of exponents to logs. So first things first, we need to talk about restrictions on the domain. If you remember on the picture of, the graph of the log equations, there was that asymptote right there. So what happened was your x values were restricted. We couldn't go past that asymptote. So for a regular old one, whether it's ln of x or log base b of x, there were restrictions because of that wall, right? That vertical asymptote. Whoa. What that means is there is no solution to when you try and take the log of a negative number. To define a domain, you just have to figure out where the stuff inside is greater than 0. So you literally take the stuff inside, x minus 1. You make an inequality with greater than 0, not or equal to, just greater than 0. Finish solving for x. This says right here, my domain is x greater than 1. So if I go through and I solve any of these equations, so let's say I solved this, right? Solved and got x equals -2. You would compare that to your domain and say it's not in the domain. So -2 is what's called an extraneous solution. It does not work. Came out of our solving, but it doesn't actually work with the original problem. So you would say it's not a solution. So you cross it out of your answers. So that should be one of the first things you do is you go through and you figure out what your domain is so that in the end, when you get your answers, if you have an extraneous one, you cross it out. If you try and enter both answers, like on a test, then it's going to mark it wrong if one of them is extraneous. Okay, simple. We've got 8, log base 4 of 8 minus 2x. Doesn't matter the base, doesn't matter anything except for that inequality right there. Finish solving for x. Divide by -2. Hopefully you remember that that flips the inequality. This says x has to be less than 4. So there's your domain. If you were to get 5 as an answer, it's extraneous. If you got 3 as an answer, that's okay. Okay, ln2, same thing. Can't do ln of a negative number, so we find this domain. Solve like normal. -4x is greater than -1. Divide. Don't forget to switch the sign. Sorry, the inequality. And you get x is less than 1/4. X is less than 1/4 means it can't be 1 or it can't be a half. It could be 0, it could be -1, but it's got to be less than that number. No, they're not always x less than. Okay, so the first test, or the first type that we're going to solve is when there's one log. One log, and it's actually quite simple because all we do is convert it back into an exponential form using our little handy-dandy relationship. You have to get the log alone though. So in this equation, it's log base 4 of some stuff equals 3. The log is alone, so we can continue with using this method. First things first, your domain, x plus 12 has to be greater than 0, which means x has to be greater than -12. Finish solving. You're going to convert it into exponential. So if you remember, we call it a loop. You get 4 to the third. Little baby base becomes the big base. Those guys switch sides. 3 is now the power, and that equals x plus 12. Ta-da! Right? Our x is out of the log, so now we can solve like normal. 4 to the third, that's 64. Finish solving. Whoops, minus, not divide. Looks like x is equal to 52. Now check. Is it greater than negative 12? Yes, that's it. That's not an extraneous solution. So this works when there's only one log. Only one log would you use this. Okay, here we go. Domain x plus 3 greater than 0. So I need my answers to be greater than negative 3. Converting. This becomes 4 is the big base to the 2 power. That equals x plus 3. 16 minus 3. Whoops, minus 3. X equals 13. Okay, ln is not alone. Notice this guy right here. It's 4 times ln of 2x, so we would divide by 4 to get rid of him. Ln of 2x then equals 3 now. Okay, out here to the side, I'm going to find the domain. 2x has to be greater than 0. Get rid of that 2, which means x just has to be greater than 0. All right, we're going to solve. We've got to, it's a single log, right? Just ln. So we've got to convert, you have to convert to exponential. Well, we know that ln automatically means e. The 3 goes up there, and the 2x goes over here. Finish solving, divide by 2. X is equal to e to the third divided by 2, which is about third 10.0427. So we'll say 10.04. Okay. Now this one, you notice that it's not by itself. It's got 2 things interrupting us. So we've got to add 5. Divide by 2. Get the ln of 3x. You can put in parentheses if you like. Equals 7. Now we're going to convert. Ln becomes e. 7 is its power. Equals 3x. Divide by 3. X equals e to the 7th over 3, which is about, calculator says, 365.544. So let's say 365.54. Now I forgot to check my domain. Right here, our domain is where 3x is greater than 0. Finish solving. X is greater than 0. Check. We're okay. Okay, here's the next type of problem you're going to get. Now, I look at it and I go, oh, duh, but not everybody sees this as clearly as I do. When you look at, let's see, 4x equals 36. You would divide by 4, and you would say 4x equals 9. Because there was a 4 times 9 in the 36. Right? It was 4 times 9, so when we multiplied this by x, we're multiplying it by 9, which means x equals 9. I don't know if that's a good example. The idea here is this. If I told you that the ln, some log of something, was equal to the log of something else, then by definition of equality, those have to be equal to each other. They have to be the same thing. And then you just finish solving. And of course, you've got to check your domain. Should get in the habit of always doing that. This one would be x plus 2 is greater than 0, or x is greater than negative 2. This one doesn't have a variable, so it's not going to affect the domain. Okay, x equal 2 is greater than negative 2, so we're okay. So property of equality for these guys. If they match, then drop the logs. Same thing here. If these guys match, drop the log. Drop the ln. Oops, that's not drop. That's drog. Drop the ln. All right, let's look at another one. Oh, I didn't do an example of that. Oh, I did. Right there. That's good. Okay, so first type of solving log equations is when there's only one log. You convert it to exponential. Now the other ones fall into this category to where there is more than one log. So if you look at one of the problems and there's more than one log, then it's going to be one of two types. It's going to be of the log equals log, or ln equals ln, in which case you would just drop the logs and solve. If it's not in that form, then you got to try condensing those logs together into a single log using these properties. You're going to squish them down, because at that point you should have a log equals a log, which you can convert to exponential form and then solve the remaining equation. But, sorry, turn off my phone. Remember that you've got, oh, that's cool. You cannot have extraneous solutions. So you've got to check and find your domain first before you start. Okay, this right here says, what in the world? Oh, that's a try. I clicked on that. Let's try that again. So we've got 7x minus 4 has to be greater than 0. All right, finish solving. It says x has to be greater than 4/7, which is about 0.57-ish. I'm just getting approximate so I can think in terms of a number line. This one says 2x plus 11 has to be greater than 0. Okay, 2x has to be greater than -11. X has to be greater than -11/2, which is 5.5. Okay, now picturing these together, sorry, put them up on a number line. Here is 0.57. It's just greater than, so there's a circle, and it's everything this way. This one says go to 5.5 and this way. So it would be sufficient to say that if it's greater than 0.57, then it's also greater than, or it could be also greater than 5.5. Essentially, you need to make sure that it's bigger than 0.57. Or you can always plug your answers back in and check and see if it made a negative inside there. Okay, this one is ln equals ln. So I'm going to take the insides, set them equal to each other. We drop the base. If the log matches, sorry, drop a log. If the logs match, we drop the log. It's very similar to the when the powers matched. Okay, regular old solving. 4, we get 5x equals 15, like that. We get x equals 3. Now, is 3 part of my domain? Well, here's the number line. Here's 3. Yeah, it's bigger than that number right there. So that one's okay. But like I said, if you don't like this whole method of solving for it, it confuses you a little bit, you can always just plug your value back in. So if x equals 3, then 7 times 3 minus 4 would be this guy right here. That's 21 minus 4 is 17. Is that positive? Check. Okay, the other one is 2 times 3 plus 11, this guy. That's 6 plus 11 equals 17. It works on both sides and it doesn't produce a negative, so we are A-okay.